Alright guys, so in Chapter 7 here we're going to be dealing with systems of linear equations. All first semester we solved lots of linear equations and we graphed them and we did all kinds of stuff with them. Alright, this chapter we're going to be using systems of linear equations. And a system of linear equations just means two or more equations, linear equations, with some of the same variables. Okay, so they all have x's and y's in them. They don't necessarily all have to have an x and a y, but they at least are dealing with the same type of variable. Okay, so an example of system of equations would be these two right here. All right, if you got those two equations, you could find an answer to that problem. You could find the solution, okay, which is the ordered pair, which is an x and a y, one x and one y, that together make both of those equations true. Okay, so we know that if we're just looking at this top equation, right, there's a whole bunch of x's and y's that go together that make that true. And same for this bottom equation. There's a whole bunch of x's and y's when together make this true. But there's only one set of x's and y's that's going to satisfy both of these equations at the same time. Okay, so an example of a solution to a system of linear equations is this, 3, 2. All right, now that is the actual correct answer to this system of equations that's up top. But how we get there? Well, there's multiple ways to get there. The first way I'm going to show you how to get there for this section is graphing both of them. So here it is as an example. This is the same exact example that we just used. So I said that we can solve this by graphing, but we got to remember how to graph a linear equation. All right, so if we look at just x plus 2y equals 7 first. All right, we want to graph both of these on the same coordinate plane. All right, and over here I can write the other one, 3x minus 2y equals 5. All right, I want to graph both of those on the same graph. I can't breathe. Okay, in order to graph a line, right, you got to turn it into y equals mx plus b. You got to get the y by itself. So we want to isolate these y's, get them by themselves, and then we can plot them on the coordinate plane. So in order to get this y by itself over here on the left, first need to subtract x from both sides. Okay, so you're left with 2y equals negative x plus 7. Okay, and negative x plus 7, but we still have this 2 here, so you have to divide that off. Divide everything by 2, and we've got our equation y equals negative 1/2 x, because the coefficient here in front of the x is a negative 1, since there's nothing there, plus 7 over 2, or 3.5, whichever one you're more comfortable with. All right, now that's helpful in helping us to graph this. Okay, so now we can graph it. In order to graph it, you got to go up 3.5, 1, 2, 3.5, and you put your little dot there, okay? Because this is the y-intercept, right? That's your b. And our negative 1/2 over here is m, which, as we all know, hopefully recall, is the slope. Okay, so the slope means the direction that you go from that one point. Right, so from the y-intercept at 7/2 of 3.5, right, you need to go down 1 over 2, okay, or down 1/2. All right, so we go down 1 to the right 2, and there's our next mark. All right, and you only need 2 dots in order to graph a line, and then you can just connect. Oops, that's not very good. You can just connect the dots like that. Okay. Now, same thing for this blue equation, okay? You got to get the y by itself, so we got to subtract the 3x from both sides. You're left with negative 2y equals negative 3. Oh, I should move that over some. All right, negative 2y equals negative 3x plus 5. And finally, subtract negative 2. Not subtract, sorry, divide. And we have y equals negative 3 divided by negative 2 is going to be positive 3/2 x minus 5/2, or 2.5. Okay, so the way you graph this, you got to go down 2.5s first because we've got our b, our y-intercept over here. Obviously, the 3/2 is the m. So you go start by finding the y-intercept. So we go down 2.5 or 5/2. Okay, and then from there we need to move up 3 over 2. All right, that's why I always suggest you write the slope as an improper fraction because you know it's rise over run. So if we go up 3 over 2, then we're going to be at 1/2 and 0.5 there. And once we have our 2 points, you can connect the dots. All right, now we just drew both those graphs. You got to be able to do that. Now, once you have those two graphs, you find out, well, where do they hit each other? If I drew these correctly, which it's pretty close, but not terrible. You see that they intersect right here. And what is that point? Shockingly, 3, 2. Like I said, that's the solution to the ordered pair. So that's how you do it by graphing. Graph the two equations, find out where they meet. Now, from there, we can do a couple other things. You always want to check, right? Because sometimes you might have some decimals, some fractions. So this next example is going to show us how we check our answer here. If we want to tell whether the ordered pair is a solution to the linear system, we've got this ordered pair. Okay, 6, -1. We want to find out if it's a solution to this system of equations. All right, in order to do that, you just got to plug in. We know that's an x and that's a y. So you just plug it into both of them and make sure that they both work. Okay, you could do the same thing with our 3, 2 from the previous problem just to check and make sure your answer is correct. All right, so let's do that. So with this top equation, we've got 2 times 6 plus 5 times -1 equals 7. Does that make sense? We've got 2 times 6 is 12. 5 times -1 is -5. So we've got 12 minus 5 equals 7. That works. All right, and check it for the second problem. We've got -6 plus 2 times -1 equals -8. Does this make sense? We've got -6 plus -2. -6 plus -2 is -8, so it's a yes. And it works out. That's a way to check your answer. And we'll go ahead and stop there for today. We'll go ahead and take a look at this word problem in class, and good luck, guys.